All right, hello there. This is video number 28. This is chapter 5, section 8. There's only 9, so we're almost done with this chapter. And this is about factoring using the difference of squares formula. So this is the first of what we call special cases. We'll do the last two in the next video. And all of your special cases have 2 terms. And just really quickly, recall that you're always going to take a GCF out if possible. And then if you have 4 terms, we learned how to factor by grouping. And if you have 3 terms, we learned to factor using X method. And these now all have 2 terms. And there's 3 of these. So this first one is difference of squares. That's the one we're going to talk about today. And then in the next video, we'll talk about the difference of cubes and also the sum of cubes. They're very similar to each other. All right, so the big one today, we're going to talk about difference of squares. Again, it's the first of your special cases, and all of your special cases will have 2 terms in them, okay? So the first thing I want to do is actually list out all of your perfect squares from 1 to 15. Using the bases, or the base of 1 through 15. And so what I mean by that is we have 1 squared. Well, what is 1 squared? It is 1. This 1 right here is the perfect square. Okay, 1 is the base. We're squaring it. In this case, that's the perfect square. So 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 81. No, it's not. Oh my gosh. I was thinking ahead. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. And 15 squared is 225. And I also want to just point out how to do a perfect square and take a, well, perfect square is easy, but then the opposite of squaring something is taking the root. So it's taking the square root that I want to know that you can do. Okay, so if we get 225, I'm looking at this guy here. If we get 225, the square root of 225 is 15, right? Because it means what times itself equals 225. So these are all answers for each other. And if you keep them really handy, some of you have been forced to learn these at some point in time, and that's really handy. I highly recommend you're at least familiar with them so you can go, oh, 121, I know that's something squared. You know, I don't care if you know if it's 11, you can use a calculator. But anyway, all right, so let's take a look at this calculator in case you're using it. The square root button is right above. Oh, look, I'm using red on red. That's not going to work very well. How about this guy? The square root button is right above the x squared button. So if you want to take the square root of 625, then you have to, because it's in yellow up above a key, you would have to hit second and then hit the x squared button, and then you type in the 625 and then hit equals. Okay. Now with these, if you get a whole number, then it is a perfect square. If you get a decimal, it is not, right? Some of you might be using Desmos also. So I just want to pop over here. I have this set up. So the Desmos scientific calculator, this is really nice. Your square root button is right here. And so if you want the square root of 196, because you forgot that it's 14, just hit your square root button. You don't have to hit second or anything else. Put what you want underneath the root. Oh, get rid of that keyboard. And it tells you over here on the right-hand side what the answer to that is. Now, again, whole number, right? If you don't get a whole number and you get let me go back here. All right, let's just do the square root of 50. If you stop popping that up, if you get a decimal value like we do here, then this is not a perfect square and it is completely unhelpful to us in these problems. Okay. Let's see, going back. So that covers your calculator usage. Let's see. Okay, so here's the next thing I want to have you do. I want to have you multiply 3x minus 5 times 3x plus 5. Hit pause, take a minute to do that. And if you do, when you come back, check your work. Okay, so I get 9x squared minus 15x plus 15x minus 25. And then these will cancel and you get 9x squared minus 25. All right, so the next one I want you to multiply out is, I want you to multiply x minus 4 times x plus 4. All right, and while you're doing that, I'm going to get rid of a couple of things here. Okay, so if you multiplied this all out correctly, I'm not even going to show all the steps. I'm just going to show the answer. You should get x squared minus 16. All right, so here's my question with both of these. That one and this one. How many terms are in each answer? Okay, you started out with two binomials being multiplied by each other. You ended up with answers that both had two terms, right? How about the sign between the terms? Well, notice that they're both a minus sign or a negative. Also, what do you notice if I were to actually highlight? What do you notice about the 9, the x squared, the 25, the x squared, the 16? Do you notice anything about all of those? What do they all have in common? They are all perfect squares. Even the x squared, right? Like the square root of x squared is just plain x. The square root of x to the 4th, do you know what that is? It is x squared. The square root of x to the 10th, do you know what that is? That's x to the 5th. So with a variable, you're always just cutting it in half when you're taking the square root. So that will happen for you. So those are all perfect squares. All right, so then I want you to look at what we actually started with in the blue boxes. What did we start with here and here? Well, what I want you to notice here is a couple things you should notice. If we highlight some things here, what do you notice about the values inside the parentheses? Okay, notice they're the same in both set of parentheses. They're the same in both sets of parentheses. However, one has a minus and one has a plus sign. One has a minus and one has a plus sign. Will always happen. This will always happen. Why? Because these two middle terms are going to cancel each other out, right? I didn't even bother with them in the second one I did, but they're always going to cancel each other out. So now what we're going to go do is we're going to go backwards. We're going to be given something like this, and your job is to factor it into two binomials. Okay, so you're going to be given the two terms, factor into the binomials. So let's start with, here we're going to go backwards. Okay, if we're given something like 25x squared minus 64, and you're asked to write out the two binomials, well, all you have to do is take the root of each of these, put those answers into the binomials, and then make one a plus sign and one's a minus sign. So here's what I mean by that. This is pretty straightforward, actually. So we're going to take this guy, the root of 25x squared. Well, the root of 25 is 5, and the root of x squared is x. So I'm going to take that 5x and put it in the front of both binomials. Then I'm going to take the root of the second number, and the root of 64 is 8, and that's going to go in the back of both binomials, and then one gets a plus sign and one gets a minus sign. How could you check? Oh, this is your answer, by the way. Okay, remember that you can always check by foiling or multiplying, right? And so if I take 5x plus 8 and 5x minus 8, and I FOIL that out, I get 25x squared. I get a minus 40x when I multiply here and a plus 40x when I multiply there. Those are going to cancel each other out. Minus 64. So I get here what I started with up there. And so this problem checks. And again, the answer is the two binomials that you created that multiply to the actual problem. So remember, factoring, we're taking a adding and subtracting problem and turning it into a multiplication problem. Why? Again, so we can solve later for x. That comes later. You have to learn how to do the factoring first, and then we can go and solve. That will come actually next year for you. Okay, so that's my answer. Let's do another one. Here's an example. Let me change back to an actual pen. So if you're given 100 a to the fourth minus 4, you're going to be asked to factor. Okay, well, all you're going to do is take the root of each one. So in essence, I'm taking the root of 100a to the fourth. I'm taking the root of 4. This is 10a squared. This one is 2. And so I would have 10a squared plus 2 and 10a squared minus 2. For those of you thinking, hey, there's a GCF in there is actually a GCF in there, and it could be taken out. We're not going to address that at the moment, because if I take it out, well, I could take one out here. We're just going to leave that alone for now. All right, another example that I know you're going to see in varsity looks like this. 3a to the 7th minus 3a. Remember, you always need to take a GCF out first. Also, if you find you have a number that's not a perfect square, then you should look for a GCF. Okay, so you should have numbers that are perfect squares. So we're going to take a 3a out of here. That's going to leave me with an a to the 6th minus 1. Well, now this part and just this part can be factored using difference of squares. Just take the square root of each piece, the root of a to the sixth and the root of 1. Well, the root of a to the sixth is a cubed, and the root of 1 is 1. So what we're going to do in our answer is drop down our 3a, and then our two binomials are going to look like a cubed plus 1 and a cubed minus 1. Okay? For those of you that like formulas, there is a formula for this. And, oh geez, little dyslexia happening right there. Did you see what I did? I switched the last two letters. Formula. Okay, so you're given something in the form of a squared minus b squared. Again, looking at the top of the page, that's this guy right here. A squared minus b squared. You have to factor something out first to make it happen, but you're going to factor it into a plus b and a minus b. And when you are given something squared and you want to get to something not squared, so you're given something squared and you need to get to something not squared, you're going to take the square root of a squared and b squared, and then just fill in the parentheses. So if you don't see it, you know, what's happening up at the top, you can't see that those are perfect squares. Some of you like formulas, and the more familiar you are with the formulas, I think the more successful you are in the long run. Okay, one last example, just so you don't get stuck in varsity. What if you're given this? 1 over 256 a to the fourth minus 1 over 625. Well, you can treat a fraction just like you would treat a whole number. So here's what you should know. If you have just a number, 9, and you take the root and you get a 3. Well, if you have a fraction, let's say 1 over 25, and you take the root of that, that's the same as taking the root of the top and the root of the bottom. And so this would equal 1 over 5. Okay, so that's essentially exactly what's going to happen here. So all you're doing is taking the root of the top, root of the bottom, right? So root of the top, root of the bottom, root of the top, root of the bottom, the root of a to the fourth. So the root of 256 is actually 16, and the root of 625 is 25. And so when I do these, here's my binomials. I'm going to take the root of 1 over 256. Well, the root of 1 is 1. And so I get 1 over 16. The root of a to the fourth is a squared. And the root of 1 over 625 is 1 over 25. And then I have 1 over 16 a to the second minus 1 over 25. Okay? And that's the answer to that guy. Again, if you multiply that out, you would get that same answer. So if you don't understand what happened there and the fractions are throwing you off, don't let them throw you off. Just, use your calculator and figure those out. All right. Well, that's it for now. Toodaloo.